Hi, my name is Maarten Broekmans. I'm of Dutch origin. I have been working at NGU for 17 years. I've been professionally educated as a geologist with main interest areas in mineralogy, applied mineralogy and geochemistry. I work daily mostly with the mineralogy of cement and concrete, which couldn't be grayer from a topic from a geology point of view, but concrete is perhaps and arguably the thing that comes closest to geology for society, because we're using concrete every day. Everyone is using it. To get access to concrete, we drill cores from field structures, like this one. This is an example. This one came out as a whole core, was then impregnated in a laboratory with a fluorescent resin, hence the greenish yellowish color, and then sliced to reveal its interior, in which you can easily recognize the individual aggregate particles. This is a core of Dutch concrete. It is actually quite amazing, because if we look at it in a different way, we can see that it is full of damage. And I'll use a different kind of illumination for that. So here is the very same core in plain light, and it looks like ordinary concrete. But big surprise, if we turn off the light and see it in UV light, and now you see why it is good to impregnate the core. Now you see that it contains a lot of cracks, and the concrete is designed to be crack-free. And the funny thing is that you see that some of the cracks actually go right through certain particles, like here. And this is the original surface, and you see that some cracks emerge right at the surface. To assess the concrete in the core and know and understand why the cracks are there, we produce thin sections in a special way. These are also fluorescence impregnated, as you can see here. They result in thin sections very much like this one, which we then put under the microscope and can study in very great detail. Here you see a detail. This is a chert particle with cracks in it and an air void, and if you look in greater detail, you can see that the air void is actually lined with something that is gel, and it is this gel that causes the damage. And in fluorescent light, just similar as used for the full core, we can recognize that there are cracks and porous parts inside the aggregate grain. This is the aggregate grain, and this is the rest of the concrete with the fine aggregate particles, the sand. And you can see that this crack is breaking up the interior of the large aggregate particle. That is only one type of damage, which is particularly devastating, because structures cannot really be repaired and have to be replaced. So that is, if you have that kind of damage, it's going to be very expensive. Luckily, there are many more concrete damage types, and these are not that serious as that particular one, and which can be repaired, but still you need to know what the origin of the damage is before you apply and determine for a repair strategy. Concrete damage may seem like a fringe subject, but we use concrete throughout our society for power plants, railroads, ordinary roads for all kinds of traffic, harbors, coastal defense works, and society relies entirely on the reliability of the structures that it makes. And the people living behind a large dam rely on it, that it protects them against flood. The people for using power from the wall sockets rely on the power plant being safe and capable of delivering power for many decades. And that is why durability of concrete is important, and that is why we need to know and understand the processes that introduce damage to those structures. Concrete is a man-made material, but it is made with natural materials, sand and gravel as aggregate, but also the cement is a natural material, burned limestone plus some additions. And who else understands these materials better than a geologist? So next time when you're driving over, under, or along or across a concrete structure, think of geologists who do all the hard work to understand the damage processes. Thank you very much.